Okay, so the third index law is a fairly straightforward one, but it can be a bit confusing if you're not quite sure why everything has to equal 1 all the time. And it can get you into a bit of trouble once the problems get a bit more challenging. So let's try and break this down and use an example. If we had 2 to the 3 divided by 2 to the 3, then we can actually work out what 2 to the 3 is. So 2 to the 3 just means 2 times 2 times 2, and so that's the same over here, 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8, so all of that equals 8. And all of this would also equal 8. So really what we're asking is 8 divided by 8. And we know that any number divided by itself is 1. So 8 divided by 8 equals 1. Now, the same thing applies if we're using algebra. So if we are using algebra instead of numbers, so if we had a to the 3 divided by a to the 3, then it doesn't matter what a is. We don't know at the moment what it is, but it doesn't matter what it is because it's the same number. So it's the same number, and because it's the same power, then we're going to end up dividing that same number by itself, which is going to lead us back to the same answer of 1. So that's really why everything raised to the power of 0 equals 1. And we can just do one more example to sort of show that. If we think about the number 2, the base number 2, and so if we start with 2 squared and 2 to the 3 and 2 to the 4 and 2 to the 5 and so on, we could keep on going forever, then if we wrote down what this actually equaled, 2 squared means 2 times 2, so that's 4. 2 cubed is 2 times 2 times 2, so that's 8. And then this would be 16, and this would be 32. And if we come back the other way, then 2 to the 1 would have to be 2. So you can see as we move back this way, everything is halved. We're dividing by 2. So coming back, 2 to the 1, we're going to halve this, and that's going to be 2. So if we came back to 2 to the 0, then we would need to halve this number, and so half of 2 is 1, so we end up at 1. And so that's just another way to show that when we work back to the 0 power, everything ends up being 1. So let's have a look at a few examples, because they are fairly straightforward, but sometimes when you have coefficients and other things involved, it can just spoil the party a bit. So if we have something pretty simple, 3 to the 0, that's just going to be 1. The 3 is raised to the 0 power, and so the answer is 1. If we have something like k to the 3 all to the power of 0, now this is using one of the other index laws, and this other index law tells us that when you have something inside the brackets raised to a power, then we multiply these powers. So in our answer, we're going to say k to the 3 times 0, and so that will equal k to the 0, because 3 times 0 is 0. And now we're back to a 0 problem again, and so k to the 0 is just 1. Let's have a look at another one. So in this one, we've got 4a to the 0, and we want to know what that equals. So in this problem, it's helpful to remember that what we have here is 4 times a to the 0. These are sort of two separate things in a way. So what that really means is 4 times a to the 0. And in algebra, we just don't show the multiplying sign, and that's why it looks like it's all one thing together. So when we come to apply the 0 power, that is only working on the a. So this box here, this red box with the a to the 0, that is worth 1, but the rest of the answer, the 4, is still going to be a 4. So we've got 4 times a to the 0, which is 1. So now we're left with 4 times 1, which is 4. Let's just try one more like that. So let's say we've got 12a to the 0. So when we solve this one, we just need to remember that this is 12 times a to the 0, and that 0 is only working on the a. So when we come to solve it, we've still got the 12 there. 12 times a to the 0, which is 1, and so the answer will be 12.